Hello everyone, this is a lesson video for 2.14 which talks about slope, length, and midpoint. I know we've talked about slope the last few lessons, but we just want to clarify, we just want to really focus in on the fact that slope on a graph looks like rise over run, and we always go from a left coordinate point to a right one. So we always read the graph from left to right. So you want to find areas where the line hits exact coordinates on your graph. So like right here and here. And so since we're doing rise first, that means we're going to go up. I'll clarify this. We go up or we go down first. Since we're going up, we go 1, 2, 3, 4, 5, 6, 7, 8, 9. So we went up 9. And then we go over 1, 2, 3, 4, 5, 6, 7, 8. And so our run was 8. Remember, the run is to the left or to the right. So our rise was 9 and our run was 8. Now, sometimes you are given 2 points and we need to find the slope of a line. So the equation for slope of a line from 2 points is just the change of your y's, which is y2 minus y1, and then over the change of your x's, which is x2 minus x1. And the 2's and the 1's, that comes from your first point and your second point, okay? It doesn't matter which one you call point 1 or point 2, but if we have xy and then xy, okay? If this is our x1, then this would be our y1. If this is our x2, then this would be our y2. Okay, so let's take a look at this example. We have the points 2, -5, and then we have -1, -1. So we have x and y, x and y. And like I said, it doesn't matter which one you call point 1 or point 2, but if this is our 1, if this is the x of our first point, then this has to be the y of our first point. If this is the x of our second point, then this has to be the y of the second point. So now we've got them labeled, which I highly suggest you labeling them. It just makes it much easier, especially when we go to plug in for our distance formula and for our midpoint formula. So we have 2, -5, and then -1, -1. So our formula says y2 minus y1, which would be our y2 is a -1, minus my y1, which is a -5. You've got to make sure that you put that minus in there, and you can't forget to put the negative with your coordinate. The next one says x2 minus x1. Okay, so down over here, our x2 is a -1 minus our x1, which is just a 2. So filling in here, remember that whenever you have minus a negative, those are going to become positive. They cancel each other out. So when we have -1 plus 5, that ends up being 4. And then the bottom, you have -1 minus 2, which ends up being -3. So just to be clear, the slope would be -4/3. Okay, now we're going to take a look at the distance formula. The distance formula is a lot like that slope formula when we're given 2 points, okay? We have an x1, y1, we have an x2, y2, and we plug it into this formula here for distance, okay? Notice that all of this subtraction and squaring, all of it is underneath the square root sign, okay? Now, you can plug all of this into your calculator if you wish, okay? But make sure that your notation is correct when you put it into the calculator, because when you hit the square root button, it will automatically put a parenthesis, and then you need to go ahead and you need to put your other parenthesis for your x2 minus x1. Squared and then plus, and then you'll have your y2 minus y1 squared, and then you have to close out the parenthesis. So I'm going to highlight these so you can really see what I'm talking about with the parentheses. The parenthesis that opens up with the calculator, that just says all of this stuff has to be underneath the square root. So you have to close it at the end, okay? Okay, let's take a look at the example that we're given. So it says find the distance between the 2 points. So we have, let's label them. So we have our x and our y. We have our x and our y. Remember, if this is the x1, then this has to be the y1. If this is x2, then this has to be y2. So now we are ready to put it into our distance formula. So here's our square root, okay? And I am going to put this into my calculator, or I'll work it out for us. But remember, when we put it into our when we put it into our calculator, you have to do another parenthesis there. So you have, let's do the first one. It says x2. So our x2 is a -2 minus our x1, which is a 5. Close parenthesis, square it. We have plus, okay, we have a y2, which is our 7, minus a y1, which is our 8. Close it, square it. Okay, now like I said, when we put this into our calculator, you have to make sure that you put it another set of parentheses. Still doing it by hand though, just to show those of you that are doing it by hand. -2 minus 5 would be a -7 squared plus 7 minus 8, which would be a -1, and then square it. So we have -7 squared, and since that's in parentheses, it's going to make our product positive. So it becomes a 49 plus, and we have a -1 squared, which would be just a +1. So our distance is going to be the square root of 50. And you could put that into the calculator. So just the square root of 50. The distance ends up being 7.07. Okay, let's look at this one here. It says find the distance, or what is the distance between the points. I'm going to go ahead and graph these, okay? Remember that when we're graphing, we can do the x first and then the y. So starting at my origin, I'm going to go over 1, 2, 3, 4 for my x. And then since it's a -5, I'm going to go down 1, 2, 3, 4, 5. So there's my first point, 4, -5. The next point is a -1, 2. So since my x is -1, I go to the left, and then I go up 2. So the point is -1, 2. Now in the coming units, when we talk about the Pythagorean theorem, we'll talk about how you can use Pythagorean theorem to find the distance between 2 points. So I just want to show that really quickly, that we're trying to find the distance between these 2 points here. But you can create a right triangle right there. And you can use Pythagorean theorem, saying that we go down 1, 2, 3, 4, 5, 6, 7, and over 1, 2, 3, 4, 5. So you could use Pythagorean theorem to find the length of that line segment. I'm going to go ahead, while we're talking about this though, I'm going to go ahead and use the distance formula. Okay, so we have, oh, I didn't label these, did I? x1, y1, x2, y2. So our x2 is a -1 minus our x1, which is a 4. Close the parentheses, square it, plus, okay, we have y2, which is 2, minus our y1, which is a -5. Close parentheses, square it. So we have -5 squared plus, remember these minus a negative becomes a positive, so you have 7 squared. So we have -5 squared, which becomes 25, plus 7 squared, which is 49. So we have 25 plus 49, which gets us 74. And when we put the square root of 74 into our calculator, we get 8.6. Okay, now we're going to talk about the midpoint, okay? So we've talked about the distance from one point to the other. Now let's do the midpoint, where we are trying to find the exact location between two, or the exact middle between two given points. So our points here, we have 1, 1, and then 5, 7. Okay, and notice we still over here in the formula, we have our x1, y1, and we have an x2, y2. So I'm going to go ahead and label them, and I have x, y, x, y. So x1, y1, x2, y2. and putting them in. Notice that my result at the end is going to be an actual coordinate point, because what you're doing, honestly, guys, is you're finding the average of your x's and then the average of your y's. Okay, and I'm going to write that down. Average of x's and average of y's. Okay, so my two x's, I have 1 plus 5. And then there's 2 of them, so I'm going to divide by 2. Okay, for the y's, I add my y's, 1 plus 7, and then divide by 2. So I've got 1 plus 5, which is 6. I'm still dividing by 2. And that 1 plus 7, which is 8, divided by 2. So my midpoint of this line would be 6 divided by 2, which is 3, and then 8 divided by 2, which is 4. So it'd be right here at the point 3, 4. So over here the x is 3 and our y is 4. And there it is. And a lot of times they will notate the midpoint with a capital M, okay? Okay, one more example. What are the coordinates of the midpoint of the line segment with endpoints of J and K, which are at -3, 4, and then 5, 2? Now, on that last one, some of you might have been saying, why did she do the formula when you could easily see that that's a midpoint? Hey, I always want to check my work, okay? And then also, sometimes they're not going to give you a graph of it, and you need to know how to use the formula. Plus, when we use, we're actually going to use the midpoint formula in a couple of lessons later when we talk about directed line segments, okay? So we have -3, 4, and we have 5, 2. So this is our x and our y, our x and our y. x1, y1, x2, y2. So plugging them in, remember I'm adding my x's, dividing by 2, adding my y's, dividing by 2. So my two x's are -3 and 5. I'm going to divide that by 2. And then I'll have my y's, 4 plus 2 divided by 2. So let's see here. I have -3 plus 5 gives me a +2 over 2. I can't forget about that, divide by 2. And then I have 4 plus 2, which is a 6, divided by 2. So these simplify down to 1, 3. So our midpoint between points J and K, the midpoint is going to be at the coordinate 1, 3. Now here's a great wrap-up slide or note page, formula page, whatever you want to call it for the lesson 2.14. So grab a screenshot of that or take a picture of it with your phone. But I will also post this I'll post these notes from this video. I'll post it in our geometry resource page. Thanks a lot, guys. Bye-bye.